Hello friends, welcome to my channel Aug CS revision notes. So friends, as you know, we have completed all the units from the UGC NET Computer Science 2024 paper. Now we are left with data structures and algorithms. So today we'll see the problems from it. Question number 54. Dash is a self-balancing binary search tree where the path from the root to the furthest leaf is no more than twice as long as the path from the root to the nearest leaf. Search tree. So it is an expression tree, game tree, red black tree, or red tree. So red black tree is a self-balancing binary search tree where the maximum height is 2 into log n plus 1 for the n nodes. Here the longest possible path is almost twice as long as the shortest path. So cut option is option number 3. Next question number 99. Here they given the reconciliations and they've asked to arrange in increasing order of their time capacity. So to solve reconciliations, you need to know the Master's theorem. So in Master's theorem, when you use Master's theorem, you need to know the general format. So general format will be like T of n is equal to a t n by b plus f of n, where a greater than equal to 1 and b greater than 1. Here f of n will be the form or of nk n power k log p, that is log power p n. Okay, so first what we'll do, we have to find out what log ab and value of k, and then we have to compare. We have three cases, we have to substitute in, we have to find which case this occurs, and then we have to use this formula. So okay, for case 1, if log ab greater than k, then is order of n to the power of log ab. Case 2, if log ab equal to k, then there are three conditions, that is depending on the value of p, that is the value of p is order of nk log to the power of pn. So depending on the value of p, suppose I given log, so depending value of p, we had three sub cases. See, if p is greater than minus 1, if it's greater than minus 1, it's order of nk log p plus 1 to the power of log to the power of p plus 1 n. If p is equal to minus 1, then it is order of nk log of log n. If p less than minus 1, then it's order of nk. Case 3. Suppose if log ab is less than k. Again we have two cases, that is if p is greater than equal to 0, then it's order of nk log p to the log p, that is log n to the power of p, that is log pn. If p less than 0, then it's order of nk. So using this Master's theorem, we'll try to solve this problem. Here the first option is given as t of n equal to t of n by 2 plus 1. Here also you find that it is in this form, that is a t n by b plus f of n. If you notice this form, then you can use this theorem. Then as usual, you have to find out what is the value of log ab, and then to find out the value of k. See here log ab, see here a is 1 and b is 2. So you have log ab is log 1 2, which is log 1, which is the value is 0. And similarly nk means you have the value is nk is 1. So if nk is 1 means nk is value of 0 and p value is also 0. So when you have this case where you have log ab 0 and k is 0, then it goes into the case 2. So in case 2, get a order as order of n 0 log 1 log to the power of 1 n. So it is order of log n. So substituting in the case, you find the value is order of log n. Similarly, take the second option, that is t of n equal to 2t n by 2 plus n. So here also a is 1, b is 1. So log 2 base 2, which is equal to value is equal to n. And then you have value n. So n value means it is n power k. N power k is n power k is what? You have only n to the power of 1. So you don't have log. So n power 1 means what? K's value is 1. So k equal to 1 and p equal to 0. So again it goes into what case? It goes into the second case, because you have log ab is 1 and k is equal to 1, goes to case 2. So again we have the value as order of n to the power 1 log 1 n. So here you have order of n log n. So this is the value you get substituting in the second case. Next option, t of n is equal to 3t n by 3 plus n. So log ab means you have log 3 to the base 3. So similarly, you will get the value as 1 only. Similarly, you have the value as n. So nk again value becomes n, and so k is equal to 1 and p equal to 0. So again goes into the second case. So again goes into the second case. So it is order of n log n, which is order of n log n. So this is the answer for C. Now option D. So T of n equal to 2Tn by 2 plus root n. Here also you find log AB is 1 because A is 2 and B is 2. So log AB is 1. And n of k. So what is the value of k here? Now n to the power square means n to the power of half. So k becomes half. And p equal to 0. So you find that here log AB is 1 and k is half, which means that log AB is greater than k. So which condition goes? It goes into case 1. So we go to the case 1, the result will be order of n to the power of log AB. So order of n to the power of log AB, what is value? Log AB value is 1. So order of n. So the value is order of n. Next, the last option, that is E, is given as T of n is equal to T of n minus 1 plus 1. Here you see that it is not of the form like T of n is equal to. So here it is not of the form T of n equal to AT n by b plus f of n. So it is not of this form. So you cannot do this with the Master's theorem. So you have to use the substitution method because it is an easy method. Here you have to substitute the value using. See, when it's given T of n is equal to Tn minus 1, then again you take T of n minus 1. So T of n minus 1 becomes what? Plus T of n minus 2 plus 1. Again, if you have to do a substitution for n minus 2. So T of n minus 2 is what? T of n minus 3 plus 1. So use these two equations, substitute these two equations into. First you substitute the first equation, that is 2. So T of n becomes T of n minus 2 plus 1 plus this one. Okay, the first one, so plus 1. So here if you substitute is T of n minus 2 plus 2. Next, substitute for T of n minus 2 from this equation, third equation. You get T of n is equal to T of n minus 3 plus 1 plus 2. So here we get T of n minus 3 plus 3. So what will get? T of n is equal to T of n minus 3 plus 3. You continue with this, you get T of k is equal to T of n minus k plus k. So equation 4. Now in the condition where when n becomes k, so what happens? N minus k becomes 0. So n of becomes n minus k becomes k minus k. So T of 0, and you have only n. So in this equation you have only n, T of k minus k plus n. So it is T of 0 plus n, which is order of n because you have only n. Now we arrange in ascending order. You get order of log n. So how will you get the ascending order? Least will be the log n. So order of log n, then order of n, then order of n, then order of n log n, and then order of n log n. So the values is, see, order of log n is a, order of n is e, and e and d both the order of n, and then b and c is order of n log n. So the arranged order is a, e, d, b, c. Okay, yeah, arrange order is a, e, d, b, c, and cut options option number 2. So question number 99, cut option is option number 2, that is a, e, d, b, c. Question number 118, select the sorting algorithms that are stable: quick sort, bubble sort, insertion sort, merge sort, or shell sort. So you find that here bubble sort, selection sort, insertion sort, quick sort, and heap sort are in place, and merge sort is not in place algorithm. And if you find stability here, bubble sort, insertion sort, and merge sort are stable ones, and selection sort and quick sort are not stable. So here bubble sort, insertion sort, and merge sort are stable. So correct option should be B, C, and D, but they given E, so it is a wrong option. So this question was dropped. Next question number 128. So again they given a list, match list 1, list 2. They are given the recurrence relations and the complexity. So see, most of it we have already done in the previous question only. Using the Master's theorem, you can find out the complexity for these recurrence relations. So first is T of n is 2t n by 2 plus n. So here also log AB is log 2 2, which is 1, and then the value of k is 1 when p equal to 0. So it goes to the case 2 of Master's theorem, and we have order of n power 1 log power 1 n. So it's order of n log n. So option B, t of n is equal to t of n by 2 plus 1. So here also we have log AB log 1 base 2. So the value of log 1 is 0. And here nk is equal to 1 and k equals 0 and p equals 0. So it goes into the case 2 of Master theorem. So again we have order of n0 log 1 n. Here we have order of log n. Next option, t of n equal to 2t n by 2 plus 1. Here you have log AB log 2 base 2, which is equal to 1, and then again you have the value is 1. So nk is 1 means k equal to 0 and p equal to 0. So it goes into what? It goes into case 1 as log of AB is greater than k. So it gives order of n to the power of, so goes into case 1, goes into the case 1. So it is order of n to the power of log AB, which is n to the power of log 2 power 2, which is 1. So it's order of n. So the answer is order of n. Again, next option D, t of n is equal to t of n minus 1 plus 1. So it's the same question we have done in the previous problem. So again you use the substitution method and you can get the answer. T of n is equal to t of n minus 2 plus 1. Then again you substitute t of n by n minus 2 as t of n minus 3 plus 1, and then you go on till reach t of k. T of k is t of n minus k plus k. Then when n minus k is 0, then n equal to k, then you substitute t of n is equal to t of k minus k plus n. So it becomes t of 0 plus n. So it is order of n. So get the values of all the reconciliations. Here you find the option is A1, B3, C4 and D2, which is option number 3. So the answer to this question is for number 128 is 3, that is A1, B3, C4 and D2. Next final question is question number 135. Here we have to match a list 1 with list 2. So algorithms are given. So Richter algorithm, Frey-Rochelle algorithm, Bellman-Ford algorithm and Prim's algorithm. So Richter's algorithm will find what? We'll find the shortest path in a weighted graph with non-negative weightages. So Richter's algorithm works only on non-negative weightages. So the A is matched with 2. Then Floor-Warshall algorithm will find the shortest path between all the pairs of vertices in a graph. Whether it is positive or negative, will find the shortest path between all pairs of vertices. And then Bellman-Ford. So Bellman-Ford is till determine the strongest connected components in a directed graph, and Prim's algorithm will sort the elements by repeatedly by moving them past the neighboring elements. So Richter's algorithm will find the shortest path in a weighted graph with a non-negative edge weights. And Floor-Warshall algorithm will find the shortest path between all pairs of vertices in a graph with positive and negative edge weights. Bellman-Ford algorithm will determine the strongest connected components in a directed graph. And Prim's algorithm will sort the elements by repeatedly moving them post the neighboring elements that are smaller. So before the neighboring elements will be smaller, Prim's algorithm first will choose the smallest vertex which has this link with the smallest weightage. So D is 3. So what is the matches? A2, B1, C4 and D3. So correct option question number 135 is option number 2, that is A2, B1, C4 and D3. So friends, we have completed almost all the problems from August 2024 question paper. That is all problems are very easy to solve, and I think out of all the question papers, this paper is probably the most basic and most easiest paper. If you take any paper, UGC NET paper from 2018, all the question papers will be slightly difficult level, slightly more than this paper. So if you have a basic idea this paper, then after this solving this paper you can attempt all the papers. So friends, I hope this session on the August 2000 paper was very useful to you. So please do like, share, and subscribe my channel Raji CS Revision and Notes. So friends, if you want notes for the various units on UGC NET computer science paper, or need a question with the answers in PDF form, please write to me here in itismeeraji10@gmail.com, or WhatsApp this number 98406 25046. Please, if you find this useful, please share with your friends. Thank you.